So imagine we have a side view of the graph that is in the statement, right? So this is the magnetic field is moving in this direction, and we have the item that is at 30 degrees, and we know that A has to be perpendicular to the surface, so it has to be either 90 degrees from here or 90 degrees from here, right? So if that is the case, then it could be, in order to make this 90 degrees, we can think of this area here to be 60 degrees. Or if we look at from geometry, if this is 30, then this better be 30, and if this is 90, then this whole thing would be 120. So the area surface is at either 60 degrees or 120 degrees from the direction of the magnetic field, sorry. And now we know that the flux, magnetic flux, is given by the magnetic field dotted with the area, which means this is the magnetic field times the area times the cosine of the angle between them. And we need cosine to be positive, because we're told that the magnetic field is positive and it has a positive surface area, and the flux then would be positive because the magnetic field is hitting the surface area. So cosine must be also positive, which means we will use the 60 degrees. So since phi, B, and A are positive, cosine of theta must also be positive, and that means that theta is 60 degrees. So we will rule the 120 out, and if phi b, or the magnetic flux, is BA cosine theta, then the magnetic field B is the flux divided by A cosine theta, which is 0.9 times 10 to the minus 3 Weber over 3.0 times 10 to the minus 4 meters squared, which is the area, times cosine of 60 degrees, which gives us about 6.0 Teslas.